be cool because it'll record anything on your screen. See if that's going to work. It doesn't seem to like us right now. Am I recording? Let's see. Yes, I'm recording. Okay, so this is Friday paper 25 that's due February 19th, and I am in my Algebra 1 class working on this paper. So we're going to start on number 9. Anyone in the class want to help with number 9? Find the sum of these two numbers that are in scientific notation, and then our answer needs to be in scientific notation. And I gave you a little hint. So what does that mean? Same exponents. Andrew, are you on here? Crickets. Okay. So when we're adding in scientific notation, our exponents need to be the same. And so in order to accomplish that, we're going to have to manipulate the scientific notation and thus manipulate the decimal point. So we got a choice. We can either make this times 10 to the 7th, or we can take this one down times 10 to the 6th. So it doesn't really matter. So which do you prefer, guys? Van, you choose.
What am I choosing?
Do you want the 6 to become a 7 or the 7 to become a 6?
The 7 to become a 6.
Okay, so we're going to bring it down. So Lars, L-A-R-S, is our rule. So we're subtracting from that exponent. So that's where the R is. That means we need to move the decimal to the right. So that instead of 9 3/10, it's 93. We're going to make it 93 times 10 to the 6th power. Notice that's still going to be the same value. It's still going to have the same value when I write it in standard form. But I now have the same exponent. So 8 times 10 to the 6th, they have the same exponent, so I can simply find the sum of them. 8, 9, 10, 11, 101. What did I just do wrong? I feel like that's wrong. 101 times 10 to the 6th power. Now, what's wrong with that, guys? Is it in scientific notation right now? Remember, the first number has to be between 1 and 10, right? And it's way too big. So we need to manipulate a decimal for that first number so that we get a number between 1 and 10. So I'm going to take the decimal. If it's out of sight, it's on the right, and move it 2 places to the left, right? So if I'm going left, I have to add to my exponent. So I went left 2, so I have to add 2 here. So what's my answer actually going to end up being? Uh. 1.01 times 10 to the 8th power, right? So we now have it in scientific notation, and we found the sum. Okay, so let's do number 10. Now this time we're finding the product. And so we're multiplying. And when you're multiplying, you don't have to have the same exponents. What is that kind of like when you have one rule with a sum and another rule for a product? What is that kind of like? What does that bring back to memory? Does it remind you guys of fractions? I know, like, it brings my mind back to fractions because I remember, okay, when I'm adding or subtracting fractions, I have to have a common denominator, right? And when I'm multiplying, fractions or dividing fractions, I don't need that common denominator. So it kind of gives it a place in my brain to be like, okay, adding and subtracting has different rules than multiplying and dividing. So same thing with scientific notation. So we have 2 and 74 hundredths times 10 to the 11th and 3 and 2 tenths times 10 to the negative 5th power. So the good news is all we have to do is multiply those first numbers, right? So give it a try on your piece of paper or whatever you're working on and see if you get the same thing I do. Okay, so anybody get the same numbers? Can you help me feel better about my math this morning? Crickets. It really is a whole class of people. We're going to have to move, we're going to have to place that decimal. Let's see, there's 1, 2, 3 places behind those decimals. So 1, 2, 3. And then we're dealing with the scientific notation. So I have 10 to the 11th times 10 to the negative 5th. So if you look at it, what's the word? Isolated from, or from the other part, it's just like we're multiplying here. We have the same base. So what do we do with these exponents? Do we add them or subtract them, multiply them, divide them? What do we do? Nobody wants to be on my video today. So when we're multiplying those and we have the same base, we're just going to add those. So 11 plus negative 5, what is that? 11, 10, 9, 8, 7, 6. So we have a positive 6, right? Equals 10 to the 6. So now we're going to put that all together. And let's make sure it's in scientific notation. All right, so the first number is between 1 and 10. So we are all good. We don't have to use Lars. We don't have to move that decimal. So on our line, 8.768 times 10 to the 6th power, and we're all good. All right. Now, so far we've done on the video today, 9 and 10 and 7 and 8 and 2 are done. 12 is done on a video. 13 is done on a video. Okay. So I want to look at number 14. 14. Let's do 14. Now, this is one I think you guys are pretty good at. We're choosing all the rational numbers, right? So rational, you see the word ratio, right? So any rational number can be expressed as a ratio. So immediately I'm like, bam, that's a ratio. A ratio is just a fraction, right? Can I express 34 hundredths as a fraction or a ratio? 34 hundredths? Why, yes, Mrs. Golding, I can. 34 hundredths. So that would be 34 over 100, and you could simplify that. What would that be? 17 over 50? Yeah, in simplest form. So how about 9 and whatever, 2,567 tenths, hundredths, thousand, tens, thousandths. Whoosh. Yes, we could definitely express that as a fraction and be a very complicated one. Negative 14, you could make it negative 14 over 1. So the fact that it's negative does not hinder it from being rational, okay? So the fact that it's a decimal doesn't hinder it from being a fraction, a rational number. Now, the square root of 36. So what is the square root of 36?
6.
Nice. Somebody's going to talk. Yay. So the square root of 36 is 6. That's definitely rational, right? What would that? We could make it 12 over 2, right? That's an interesting ratio that is equal to 6. So now here's the one that we're having trouble with. Square root of 45. Is that a perfect square? It's not, right? I can't build a square with side lengths that are going to be the same and have an area of 45. So when you have a non-perfect square like that, then it's going to be, if you punch it into the calculator, it's going to end up being a decimal that goes on and on and on. So the only non-rational one is this one. So we're going to select all of these. I believe in Teacher Made, did I make it a selection box where you can just select them instead of writing them out? Is it a checkbox? Maybe. Let's look. Teacher Made. Teacher Made. Yes. Nope. Let's see. Wrong question. So here you're going to choose all the rationals. So you're going to select chink, 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 chunk, chunk, all of them except for the square root of 45. Okay. Whoops. Now I'm totally lost. Let's go back here. Okay. We now have accomplished how many today? 1, 2, 3. Let's do one more for our video today. And then we will have done quite a lot. Normally what we would have done in class probably. So I'll let you guys choose. Anybody? Does anybody recognize the problem I put here at the end, 17 through 21 and 22? Anybody recognize it? You've seen this problem before. Do you know where you saw it before? Do you remember? Nobody? This was actually a problem in ClearSight. And the people that make ClearSight are the same people that make iLearn. And so I thought, well, it's probably a good idea that we look at problems like these because that's likely what we might see on iLearn. So they like this idea of multi-step things where you can accomplish a lot of different things at once. So in this table, right, we're comparing some things. So it's a survey, so it's results from a survey, and they were looking at association between students who play sports and those who take dance lessons. And I don't know why they would want to know that association. I don't know, we could think creatively about it, but I don't know. The table shows some of the results of the survey. So when you look at this intersection right here, and when I say intersection, it's the intersection of those who play team sports and take dance lessons. There's 24. Now, we know that the total number of people that take dance lessons would be 120 right here, right? So I want to know how to find this box. What do I do? I know you guys know. Nobody wants to talk this morning. I'm just going to subtract, right? So I'm going to get you started on this. I'm probably not going to work through every one of these because you'll catch on quickly what to do. And hopefully maybe you kind of were like, yeah, I got that right on ClearSight, probably because that's what I did. 11, 10, 96. Let's see if I got that before. Yes, good. 96. So we know now that at that intersection, there's 96 students who do take dance lessons, but they don't play team sports. Okay? So how could you infer some of the other boxes? Like, do I have enough information to determine this box right now? I don't have any way of knowing that, right? Because I don't have enough information. But I could get that information by solving for which box?
The one under the first total one.
Got it. There's Andrew's voice. So once you solve for that box, it'll give you enough information. So this box, it'll give you enough information to get this box. And once you have that box, it's enough for this one. And now you have enough for this one. So you just kind of have to do things in the right order. I'm not going to do that arithmetic for you, but now you kind of know the process. And then question 22 says, how many students play a team sport but do not take dance lessons? So for 22, which box would that be? Play a team sport but do not take dance lessons. It would be this box right here, right? So I'm just going to go ahead and put it like that so that you'll know when you get the answer to that box, that's the answer to number 22. All right. Guys, I'm going to stop our Friday paper video. Everybody say goodbye. Don't all talk at once. Okay.